The quiz for the day asks some questions about what it means to be increasing or decreasing at an increasing or decreasing rate. Specifically, one problem was, if a function is increasing at an increasing rate, then what is the sign of its first derivative and what is the sign of its second derivative? Well, this is clearly an object of a function that's increasing, and it's increasing faster and faster, so it's increasing at an increasing rate. Since the function is increasing, its slope is positive. Since its slope is positive, its first derivative is going to be greater than 0, so the first derivative will be positive. What about the second derivative? Well, if we take two slopes, just two average slopes, let's say a chord here and a chord here, we see that the slope is increasing. What is the second derivative? It's the rate at which the slope changes. So if the slope is increasing, then the second derivative is going to be positive, because the derivative is changing at a positive rate since it's increasing. So we determine that f prime is greater than 0 since the slope is positive. The second derivative, f double prime, is positive since the slope is increasing, and also since the graph is concave upward. What about a graph that's increasing at a decreasing rate? Well, here's a picture. We're increasing, but the rate of increase is decreasing. Since the graph is increasing, the slope is going to be positive, and the first derivative is going to have to be positive. Since the slope is increasing at a decreasing rate, the slope is going to be greater here than it is here. The slope is going to be decreasing. Since the slope is decreasing, then the rate at which slope is changing is negative. A decreasing slope means the slope is changing at a negative rate. So we see that f prime is greater than 0 since the slope is positive, and f double prime is less than 0 since the slope is decreasing, and also since the graph is concave downward. If a function is decreasing at an increasing rate, what do we have? Well, the function's going to look like this. It's decreasing, and the rate at which it is decreasing is increasing. Now, this doesn't mean that the rate is increasing, it's the rate of decrease that's increasing. So we've got to be a little bit careful about that and understand that this increasing rate refers back to the decreasing behavior of the function. A function that decreases at an increasing rate is going to have a graph that looks like this. Its slope is negative, so its derivative is going to be less than 0. The slope is decreasing. Okay, the slope here is greater than the slope here. Because the slope is negative and becoming more and more negative, the slope is decreasing. Since it's decreasing, the second derivative is less than 0, and we're going to say then that we're going to also notice that the graph is concave downward, and that corresponds to a second derivative that's negative. If a graph is decreasing at a decreasing rate, it's decreasing, but the rate of decrease is getting less and less, so it's going to look like this. In this case, the derivative is negative because the slope is negative. The second derivative is positive because the slope is increasing. It's becoming less and less negative, which means it's increasing. And also we see that the graph is concave up, and that gives us a positive second derivative.